Good morning, everyone. I am Pirker, and I'm a technician and consultant at the ACDH-CH. My presentation will be about the Corpus Query tool NoSketch Engine and how we used it to implement the search functionalities in VOICE 3. So the outline of my talk will be what is the sketch engine actually, the NoSketch Engine? Why do we use this tool? What were the specific challenges doing so, and what are our solutions? The NoSketch Engine, I've abbreviated to NoSke, is a Corpus query engine with a browser-based user interface. It is designed for searching in possibly very huge text corpora with linguistic annotation, and its natural habitat is was designed for the use of lexicographers to browse through huge text corpora. It is a free version of the so-called sketch engine. And if you want to have a look at the sketch engine homepage, you will find tons of documentation, which also holds true for the non-commercial NoSke. And if you want to have a glimpse at the usage of a NoSke in its standard way, namely for a text corpus, not a spoken corpus, we provide you with a link for that. Unfortunately, the text corpora are in German. The text corpus there is in German, but the tool, the surface is in English. So why did we end up using the NoSketch engine? So as Omar pointed already out, the XML database is used before, posed huge problems with RAM consumption and overall layout of its resource consumption. The NoSke comes with some attractive features. First of all, small resource footprint, allegedly speed, and it comes with a powerful query language with full support of regular expression, something we like very much. It comes with a stable API, which means it is designed for being talked to by other programs, and that's actually exactly what we do. And last but not least, we know it quite well. We employed this tool in numerous other projects. And we know if you only have a hammer, every problem tends to look like a native. So we were very tempted to hammer down our problems with using the NoSketch engine. So an overview of the NoSke, the advantages of the NoSke is it's designed for the searching text corpora with annotations. It comes with a powerful Corpus query language. It's called CQL. Disadvantages are more or less the same. It's designed for searching text corpora. It's focused on the orthographic word or token, we call it, as an atomic minimal entity. While in spoken corpora, like in voice, we typically have information on the subword units, like syllables, and emphasis on the syllable, interruption of the word, things like that. The NoSke is not designed with use cases of that in mind. And the CQL is indeed a very powerful query language, but it's overly verbose and complicated. So for simply searching a word form like pizza, you need to actually type square bracket word equals quote pizza quote squared brackets. That's basically not what we really want. What do we want? What did we aim for? As a reminder from yesterday's presentation, you are well aware, I think, that in our system, the data is stored as, the voice data is stored as TI-XML, a rather expressive XML variant. And when using the search facilities on the voice page. The data is typically rendered in other styles, most prominently the voice style or the post style. It's not usually not viewed as the original TI-XML. So our design goal one was, we called it, what you see is what you can search. So we want to search for constructs familiar from the voice style rendering, though the original data is in TI-XML. And we wanted to stay as close to the search styles, search syntax from prior voice versions. Stay as close as possible to that. And the other design goal is that, of course, we want to keep the information richness of the original TI. We don't want to lose information when importing our data into the sketch engine. So the baseline, the NoSketch requires the vertical format. And did I mention that? One of the cons was before that that the NoSketch does not really handle original XML, so we cannot import the XML. It requires this format called verticals. So NoSketch requires verticals, and it only understands SQL as a query language. So it means we are required to convert our TI-XML at some point to the NoSketch verticals to be able to import it to NoSketch. And it is desired for us to use our own voice query syntax, much more simple syntax, and which means we need to translate this into NoSketch SQL. And in my talk, I want to show that how this conversion, this necessary conversion into verticals and the translation into SQL is not just a nuisance, but provides us with separate handles for reaching our design goals, which are avoidance of information loss and simplicity of the query language. And now we'll provide you with a short description of both the vertical data format and the SQL query language. The vertical format in its core is called tabular separated value format, TSV. Similar to what you may know as CSV, which is comma separated, but instead of commas, it uses tabs. So each line, as you see, holds information for just one token, and the columns in the line hold the information of that freely definable attributes of the token. And attributes in voice are obviously the word, orthographic transcription, the lemma, and from yesterday you maybe know, you remember that there are these two types of part of speech tags, one for the syntagmatic function, one for the morphological function, and we also have we added the attribute called PF where we put those two together. In this example, see, for instance, in I is marked as both as a personal pronoun, but also as a discourse marker. And for learned, for instance, you have the learned obviously has the lemma learn. That's a very easy format. It has been noted that the NoSketch Engine is completely agnostic when it comes to what sort of attributes you throw there, you put there. You can define any number of attributes, call them whatever you like, put whatever information you want in there. So it's whether it's Arabic or a telephone book, the NoSketch actually doesn't care. In addition to this tabulated data I showed you before, the NoSketch allows for adding XML tags. This in a text-based corpus is usually used for adding structural information like what is the document, what is the paragraph, what is a sentence. these XML elements can be freely defined. You can put in whatever you want. In the obvious things you find in the context of voice is that we have structural elements for use XML elements for structuring the verticals into utterances, and but we also use it for encoding things like emphasis, as you see in this example. So let's have a look at the CQL. I provided you with a short glimpse before. So the when explaining the verticals, I distinguish between, say, tokens on the one hand and these additional XML elements on the other hand. Accordingly, also the CQL distinguishes between these two types of information. So when you're searching for token, the abstract pattern is use squared brackets, tell the search engine which attribute you are searching in, and then equal, and then the real search string. So just look for a word. Word is in the word form, but also for lemma or for the part of speech tag. It's always the same pattern. Attributes equals something. So the obvious custom tweaks we apply to make it more comfortable is use the attribute word as a default. So instead of word equals quote mean and everything in the brackets, you just can type the word as is, mean. This is automatically, mean is automatically translated into the more complex original SQL. We use an abbreviated syntax when you cannot rely on the, when we do not search for a word, but for another attribute, we have an abbreviated syntax, just typing the attribute name with colon followed by the value. So it's L colon house instead of square bracket lemma house, etc. And last but not least, peculiarity in the voice encoding is that all words are lowercase, only part of speech tags are uppercase. So when we encounter an uppercase letter in our search string, we know that the user actually is looking for a part of speech tag, and this can be just automatically translated. So just type VVP and it will search for the part of speech tag VVP. Next slide. For searching XML tags in SQL, you basically also in the original SQL, you type the XML as is. So if you search for emphasis, you just type angle bracket emphasis, or if you search for a certain utterance from a specific user, you can type it like that. Yesterday you saw there are additional constructs like contains and within, which is provided by the SQL. For our voice query, our custom voice query, we basically do take the constructs provided by SQL as is. So there's not much fiddling around. So what were the voice specific modification to the verticals? So one of the simple but very important things is that we retained all the XML IDs from the original TI in the verticals. So in the original TI, each and every snippet has its unique ID, and we copied that into the verticals. This allows us to have always this one-to-one coupling between results returned from the NoSketch and the original TI. So when we search for something in the NoSketch, we are basically only interested in these IDs which are returned together with this found text. And with the help of these IDs, we can identify the original XML snippets, which then will be rendered. I think Omar will recap this in more concisely later on. Because the NoSketch does not impose any restrictions on the type and number of XML elements you can add to the verticals, we make use of that. And the first hand, we just kept the original XML tags as is in the verticals, but we also added, we call it aliases. So for instance, the original encoding of foreign language snippets in voice is using this foreign tag in TI, which is highlighted in red on the slide. But in addition, we just automatically added the 3 other types. So for foreign type L1, we just added, as you see, that tag for L, one for L1, and then one for L1. These are all labels which users are familiar with in the voice style, and so we achieve this. What you see in voice, you can search for in your search query as is, just by adding additional XML tags into the verticals. Can we do something similar with token? Can we add token as we like? It's a yes, but very special precautions are required for doing that. So what are use cases for such a thing? Pauses, for instance, are in XML TI encoded as a pause tag, as you see highlighted in red again. But in the pause style specifically, pauses are treated more like token. They have a part of speech tag. And so we add, in addition to the original pause, we add a token with _1 for encoding a pause with a duration of 1 second. We call this kind of token pseudo token. So it's an extra addition. But these pseudo tokens, as you know, the Sketch Engine does not care about additional. As I said before, the Sketch Engine is quite agnostic to what sort of data you put there. And if you put this extra token there, this will break the search for multi-words, because for the Sketch Engine doesn't have a concept of a ignorable pseudo token. Therefore, if you search for something like a question and the actual data is a, so if in your data you have a followed by pause by question, and we encoded this as a pseudo token _1 question, we will not be able to find the word pair a question anymore, because in the underlying data, these two words are not adjacent anymore. So there is a solution for that, and it is as follows. We take care that all these pseudo tokens are marked unambiguously, so they can be automatically identified by our program. And we just chose the convention that they always start with an underscore. So pauses become _1. I think a lauter becomes underscore at sign, things like that. And more important, when creating our CQL, we automatically add an expression, allow any number of pseudo-token in between any two words. So in CQL terms, a pizza becomes search for the word a, search for the word pizza, but in between, you see it in red, allow any number of words which start with an underscore. These are our pseudo-token. This might sound like quite a superfluous academic discussion, but this pseudo-token stuff. But actually, this mechanism we came up with solves a real problem, namely the problem I mentioned before, that because the NoSketch was designed for using the undisturbed orthographic word as its minimal unit, but there was no, in the original system, no way to nicely handle the many cases we have where we have subword units annotated with information. So annotations on the subword level are very common in spoken languages. In spoken corpora, in voice, we have, for instance, a word like margarita, where the Rita part is marked as overlapping with another speech event. We have, example here, the word extremely, where the silver dream is emphasized. And I showed on the slide, you see how this word, for instance, extremely looks like in the original TI. So it's represented, dissected into 3 snippets. So, and how to deal with that? If we keep it as is, keep these 3 snippets, we lose the overall word. There's no way to search for extreme then, because it doesn't exist. It would be X and dream and Lee. If on the other hand, we get rid of this fragmentation, then we lose important information, because we want to know that at some point that it is the silver dream that was emphasized. So what to do? We again employ this pseudo-token mechanism. And what we do is we add the unfragmented words, in our case it's extremely, as a normal token. So it will be searchable. It has the proper part of speech tag. And as you see, it has the bears not one XML ID, but it keeps the XML IDs of all the fragments. And in addition, we keep the fragments like the dream and the Lee syllable in place, but transform them to pseudo-tokens. So they now are only placeholders kept in the verticals, which are placeholders which are due to our ignore any pseudo-tokens in multi-word searches are ignored. They don't disturb our normal search. That's all from my side. So I introduced you with the NoSketch Engine, its verticals and the CQL, and I tried to show you how we adapted this. On the other one hand, adapted the verticals. On the other hand, adapted the CQL. And I hope I could show you that this was not just a nuisance, but having these two ways to adapt and manipulate actually helped us to use the NoSketch search engine for a task which it was not designed at all, and which gives, with this solution at hand, it gives us the freedom to to bring the NoSketch engine to completely new types of corpora and search problems in the future.